Hello, good evening, everyone. I hope I am audible.
Yes, sir, you're audible, sir.
Okay, thank you, thank you. Okay, so we'll just do one question for revision and then continue further. Okay, so this is the question. We have got a function f of x for x less than equal to 1. It is defined by x, and for x square plus bx plus c when x is greater than 1. So it is told to me that f of x is differentiable at x is equal to 1. So obviously, if it is differentiable, then I can also say that it is continuous. So we should go for the continuity test first. Let me see who all are present today. Vignesh, Bhavna, Omkar. Okay. So I hope all of you remember Vignesh, Bhavna, and Omkar that if a function is differentiable, it is also continuous. Do you all
Yes,
agree?
yes,
Okay,
sir.
great. So go for the continuity test first. So at x is equal to 1, f of 1 is 1, right? And also, like you can take f of 1 minus, that will also be 1, right? Let us look at f of 1 plus. So 1 plus, so you can just directly substitute 1, right? It is a polynomial, so you can just directly substitute your value x is equal to 1 in this polynomial. So you'll get 1 plus b plus c, right?
Yes,
Correct?
sir.
Okay. So these three values should be equal. So that means 1 plus b plus c is equal to 1. So that means b plus c is equal to 0. So we have got this as our first equation. After going for continuity check, we should go for checking if the derivative exists or not. We should go for derivative test. So let us go for the derivative test. So can you just tell me what will be the derivative of this thing? X, what is the derivative of x?
Sir, it is 1, sir.
1, great. And what about x square plus bx plus c?
Sir, it will be 2x b only, sir.
2x plus b, great. So we need to check at x is equal to 1, right? So at x is equal to 1, can you tell me what will be the left hand derivative? At x is equal to 1, what will be the left hand derivative?
1, sir.
1.
1, great. And what about the right hand derivative? That means f dash of 1
Sir, it
plus
is 2 plus b.
2 plus b, great.
Yes.
So 1 and 2 plus b both should be equal, right?
Yes.
So your value of b is minus 1, right? We have got this. And b plus c is equal to 0. So that means c is equal to 1. You have got this. So we have got the values of b and c. Really simple, right? Okay, so great. So this was just for revision. Fine, so let us just look at a few theorems on differentiability. We had done a few theorems on continuity also. So let us just try to see if are there any common things between differentiability and continuity. So uh, so you have got two functions, f of x and g of x, and I am adding or subtracting these two functions. So what can we comment on its differentiability? What can we comment on their differentiability? So if we are adding or subtracting two functions. So the addition or subtraction of two functions is differentiable only if both functions are differentiable. Right? If one of them fails to be differentiable, then it will not be a differentiable function. Like you can think of it really simple, that you have got two functions. So like the derivative of this thing will be f dash x plus minus g dash x. So if one of these is not differentiable, so it will give a different limit in left hand limit and right hand limit. It will give you a different value. So this whole thing will not tend to be the same value, right? So it will give you a different value, so it will fail. Fine. Then, okay, so it is the other way around in product. So in continuity, what was happening? In continuity, if I assume that two functions are non-continuous, or even one of the functions was non-continuous, the entire product or the entire division was not continuous, right? But here it will not work. See, what happened in continuity was, if I was taking product of two functions and one of them was non-continuous, right? So what happened, that the product of the functions or the quotient of the two functions was not continuous. But over here, it doesn't work like that. So the product or quotient of two functions may or may not be differentiable. It may be possible that one of the functions is not differentiable and still the product is. So let me give you an example in this case. We have discussed this example earlier also. So we saw that mod x, we assumed the function, let us assume function f of x to be mod x. So at x is equal to 0, what is happening to the function? Is it differentiable or not?
Differentiable.
It is differentiable.
Yes, sir.
Sure, let us
Yes, sir.
check it.
Yes, sir.
Let us check it. So f of x can be written as x when x is greater than equal to 0 and minus x when x is lesser than 0. So f dash x can be written as 1 when x is right and minus 1
Minus
when
1.
x is lesser than 0.
Minus 1.
So f dash of 0 plus, what will it be?
Sorry.
0.
F dash of 0 plus,
0.
who
1,
will tell
sir.
me? 1.
1.
1. 1.
What about f dash of 0 minus?
Minus 1, sir.
Minus 1.
So both of these values are not matching. What will happen?
Yes, sir. So it is not
It is
differentiable.
not differentiable, sir.
Not differentiable, sir.
Great, it is not differentiable.
Not
Right.
differentiable.
Now let us take this case. So this function can be written as, again, we will split it into two parts. So mod x, it will open with plus. And this thing will open with minus.
Minus x. Lesser
Right?
than 0.
So how can your f dash x be written as?
2x.
2x
2x.
and
Lesser.
minus 2x.
Minus
So can you tell me what is f dash of 0 minus?
So it is minus 2.
Minus
How
2.
much?
Minus 2.
Minus 2 into?
So 0.
It is 0. Minus 2 into 0, right? Minus
Yes,
2
sir.
into 0 is 0.
0.
And what about f dash of 0 plus?
It's also 0.
0, sir.
0.
Right. So
Yes,
see,
sir.
you can see over here. One function is mod x, the other function is x mod x. So it is basically x multiplied by this function, right? X multiplied by mod x. So mod x was not differentiable, but its product with x was differentiable. Right? So it is not the way continuity In continuity, if one of the functions was non-continuous, the entire function became non-continuous. But this is not how it works in differentiability. Fine?
Anak mo anak ibu may tutor gitu, mata tutor gitu.
Fine? Okay. Okay, so now we will be discussing cases of what non-differentiability would mean on a graph. Like just basic sense. Graphical meaning of non-differentiability. So obviously, if a function is differentiable, for example, I'm telling you that a function is differentiable, right? If a function f of x is differentiable, what does that mean? What can you infer? What do you infer? If a function,
Continuous and it
okay, great, continuous,
derivatives exist.
Yes,
great,
sir. Derivative also exists.
at any point, okay,
Yes, sir.
right? Derivative exists at that point. So, like continuous, everyone knows. Continuous means that the function can be at that point, it can be written as a continuous line, like without lifting your hand, it can be completed. But derivative
Yes.
exists. We have discussed this phrase also, derivative exists. Can anyone tell me what is meant by this phrase?
Sir, the slopes will equal at that point. Sir,
Yes, yes, correct. It is
slopes
correct.
should
So
equal.
slopes should be equal in both left side and right side.
Yes, sir.
Yes, sir.
Right. So both left hand side and right hand side, the slopes will be equal. So for example, I tell you that a function is non-differentiable. Right? I give you that a function f of x is non-differentiable. So what could be the possibilities of this thing on a graph? So let us see what could be the three possibilities on a graph. First is non-continuous. Right? So if a function is non-differentiable, so yeah, it may be possible that it is discontinuous or non-continuous. So it may look something like this, that at a point it comes till here and it continues from another point and goes something like this. So it is breaking at a given point. So it may be non-continuous, right? This is one of the possibilities.
Yes, sir.
This is one of the possibilities. Great. Okay. So second, derivatives don't match.
Non-differentiable,
Yeah.
sir.
Yeah. Derivatives don't match. So it may give you a corner, right? What is meant by a corner? So it is just a very blunt graphical representation. So for example, the curve grows something like this and then grows something like this. Okay. So let me just change the color a little bit, or let me invert it. So it gives you something like this and then gives you something like this. So at this point, you have got a peak, right? You have got a sharp value. And if you look at the left sides, if you look at the immediately left side of this curve, the function is increasing, right? The function has its slope positive, but on the immediately right hand side, it has a negative value of slope. So slopes are not matching. It has a corner. There may be many possibilities of a corner. This was a corner on the top. Similarly, we can have a corner that's pointed towards the bottom also. Maybe something like this, right? So you have got a sharp corner at this point. A sharp corner at this point, right? So the
Sir,
slopes don't match. Yes, Vignesh.
is it the slope only need to be aligned on only one quadrant and it can be on both quadrants?
No, no, it can be on the any side. Okay, so it can be on any side as you wish. Just in order to show this, I was showing it in the first quadrant. It could be something like this also. Anything, anything.
Okay, sir.
Yeah, fine. And a third possibility, which rarely comes into picture, is vertical tangent. So vertical tangent basically means that at any point it may be possible that a closed curve, you have something like a closed curve, like for example, you have an ellipse or a circle. So for example, you have this kind of ellipse. Okay, so I'm just drawing the first, the positive side of the ellipse. Or okay, just a minute. Let me take it the other way around. So at the immediate ends of the major axis, your curve is growing fully perpendicular, right? So your tangents will be perfectly parallel to your y-axis, right? So this may be a case wherein you may find that a function is discontinuous. Something like this may arise. Or like it is not for sure that it might be a closed curve only. Sometimes it may happen like this, that you have a curve that grows fully vertical and then comes down. So at this point, if you look carefully, you have got a vertical tangent, right?
Yes, sir.
Yeah. So
Slope
it is
is
a,
not defined in answer.
yes, slope is not defined.
That's
Correct.
fine.
Slope is not defined. Right? So this was a really blunt explanation for this thing. Fine. This was a really easy and simple way of explaining this. So just by looking at the curve, sometimes we are able to tell if a function is continuous or not continuous, or is differentiable or not differentiable. So let us look at uh, a very small example. So you have got f of x. Okay. F of x is given to you as, okay, let us take something like x square plus 2 times of mod x plus 1. And it is asked to you what are the points where this is non-differentiable. Fine. It is asked to you what are the points where this function f of x is non-differentiable. Have you learned how to draw the graph of a parabola? This simple parabola? I guess we have learned it in relations and functions, right? Do you all recall this? Everyone?
We were not there, sir.
Anyone who was there? Gayatri? Ashrita? You were there, right?
Yes, sir.
Okay. Okay, so I mean, we have discussed about a simple parabola. So let us see if we can do this. So for example, I give you something like really simple thing. I give you y is equal to x square minus 2x plus 1, right? So it can be written as y is equal to x minus 1 whole square, right? Something like this I give you. So like you can just clearly see from here that x square and mod x square both actually have the same value. Do you all agree with this? X
Yes,
square and
sir.
mod of x square have the same value, right? So I have basically got mod x square minus 2 times of mod x plus 1. So I can write y as mod x minus 1 whole squared. If I ask you to draw the curve of this thing, will you be able to draw y is equal to x square minus x minus 1 whole square? Anyone who can do it? Anyone? We have discussed this in relations and functions. When we were discussing relations and functions, we have discussed this.
Yes, sir.
So can you tell me How we do it?
Sir, it will be a parabola.
Great. And like, how do we
One
tell?
unit right towards.
Great. So it starts like it will have a point over here, 1, 0, right?
Yes, sir.
So it will go up something like this. And same way on this side also. It will go something like this, right? Symmetric.
Yes, sir.
Okay, great. So, okay. So now this is the curve of y is equal to x minus 1 whole square. Now it is asking me mod x minus 1 whole square. Mod of x minus 1 whole square. And first of all, parabola is a polynomial, so it is continuous.
Yes,
So
sir.
it doesn't have a sharp corner at its bottom. It doesn't have a sharp corner. It will not have a corner like this
Yes,
thing.
sir.
It doesn't have a corner. It has a smooth curve, right? Over here, it has a smooth curve. Fine. So, okay, this is the curve of y is equal to x minus 1 whole square. Can you tell me from this curve, how can you create the curve of y is equal to mod x minus 1 whole square? Like from x minus 1 whole square, how will you go to mod x minus 1 whole square? How will you convert this curve? Anyone knows? We have discussed conversion of curves. We have discussed this, right? In relations and functions. If I give you the curve of f of x, how will you like if I gave you the curve of y is equal to f of x, how will you make the curve of f of mod x? How would you do that? Anyone? Gayatri, Vignesh, Omkar, Ashrita, Bhavna was also there, I guess. From y is equal to f of x, how will you do f of mod x? Who will tell me? We have discussed this, right? Gayatri,
Sir, it all positive values, nothing.
right. Mod x will only take positive values. Like I have a simple question. You have got f of x. How will you create the curve of f of mod x? From f of
Same
x,
like
how do
f
you
of
create the
x
curve?
and this one.
Sorry?
Same like f of x.
Same like f of x. No, no one remembers. Okay, so like for the time being, you can just recall what does mod x mean? Mod x means x when x is greater than 0 and
Minus
minus x when x is lesser than 0. Okay.
greater than
So for the time being, you can just tell me if x is greater than 0, right? If x is greater than 0, so f of x and f of mod x both have the same meaning. So that means I can just easily trace back this curve on the positive side. So I will just look into the positive side of the curve and trace back, right? Now looking at the negative side, when x is negative, I need to go for minus x. From f of x, how do I create the curve of f of minus x? Anyone knows? From f of x, how to create the curve of f of minus x? Don't remember anyone? F of minus x.
Image of that graph
What
about
do you do?
y-axis.
Great, great. You take
Image.
mirror image about y-axis,
Uh,
right? You take mirror image about
y.
y-axis. Great work. You take mirror image of this curve about your y-axis. So
Yes.
when you do that, it will look something like this, right? I know it is not like freehand drawings will not be as accurate, but it will look something barely like this. So now it is asking you what are the number of points of non-differentiability of this curve? Can you tell me? We have got this curve now. What are the points of non-differentiability?
Is it two, sir?
Two. Which points? Can you tell me? So you can just look back and till now we have done it. So non-differentiability can exist in three possibilities. Either it is non-continuous, it has a corner, or it has a vertical tangent. So in this curve over here, what do you see?
Corner. Sir, when
You
x
see a
is
corner.
0.
Great, great. X is equal to 0, you see a corner, right?
Yes, sir.
X is equal to 0 is a corner. Great.
Yes, sir.
Is there any other corner discontinuity or vertical tangent that you see over here?
No, sir.
No, sir.
Anyone? Anyone who feels that this point over here is a corner? Or maybe
No.
this point over here is a corner? Anyone?
They are smooth surface.
Okay, great. They are smooth, right? Because it is a parabola. It is a parabola. So parabola is a polynomial. So every polynomial is always continuous and differentiable. Fine. Okay, so like you should have remembered this thing about how to make parabolas and convert functions. I will give you one homework related to this. Fine. Okay. So we have discussed this on how to. We have discussed today that how we can take differentiability test in a graph also. So many a times questions will be asked directly in examinations also. So they expect you to draw the curve directly, plot the curve, and then just check it graphically, which point is non-differentiable. Okay. So let us look at derivatives directly now. So for the functions which are differentiable, using the first derivative, first principle of derivative, right? So the first principle of derivative tells me that the slope of the function at any point x, at any point, so I assume a function f of x. So at any point x, if the function is differentiable, it will be limit h tends to 0, f of x plus h minus f of x whole divided by h. This will be the slope. And this is what we call derivative, derivative of that thing. This process is called differentiation, right?
Yes, sir.
Yeah, we have already done this. Like we have done this so many times before also. Okay, so okay. So till now we have discussed the derivatives of many simple functions also. And obviously you know what are the rules of calculating derivatives. So you can just tell me, and derivatives are represented as like the slope. I have a function, so it can be represented as dy by dx, right? So it is
Yes.
written as this, right? And it is also a function of x, slopes. Fine, so let us just start with the list directly. So what is the derivative of x raised to n?
Nx
And
power
it's
n
Raised
minus
to
N x raised to n minus 1. And we have given a proof of this also. Can anyone just tell me using what method did we prove this? We have proved it just the previous week. If anyone just can tell me which method did we use for proving it? Like how did we prove this thing? Anyone remembers? Yes, we
first.
did the proof of the thing.
Using
Using
first principle of derivative.
great. Using first principle. So in first principle, we got with x plus h raised to n minus x raised to n whole divided by h. After that, what did we do?
Factorial.
Factorial. Okay. So I mean, we went for the infinite expansion, right?
Yes, sir.
So we
In
went
fact,
for infinite polynomial expansion of x plus n, x plus h raised to n. And that is how we got it. Okay. So this was really simple. Can you tell me d by dx of e raised to x? What will it be?
E raised to x1 is
to x only.
Great. Just a minute. Okay, great. So d by dx of sine x, what is
Cos x, sir.
how did we
sir.
derive it? How did we derive it?
Expansion.
Okay. No, we did not go for the expansion. If you remember, we went for sine of x plus h minus sine x divided by h. After that, we used sine a minus sine b rule, right?
Yes, sir.
So after that,
Yes,
we
sir.
already knew what to do because sine h by h is 1 when h is tending to 0. So using that, we did. Great. And in using the same way, we proved this also. Can you tell me?
Minus sin x2.
Minus
Right?
sin x.
Using the same method, we did it. Okay. So for example, we have a constant multiplied by a function. So we can bring the constant outside and then just differentiate this thing. Right?
Yes.
Yes,
Yeah.
sir.
In the same way. In the same way. So for example, we have got subtraction or difference, addition or difference of two functions. So what can we do? We can just keep it as it is and just subtract it. Right?
Yes, sir.
Okay.
Yes, sir.
Now let us look at a really important rule which we have not done earlier. Right? So it is product rule. So for example, you have got product of two functions. So what will you do in this case? So what we do is we keep the first function intact, take the derivative of second function plus. Now you keep the second function intact and take the derivative of the first function. Really simple. So you just take the derivative of one function at a time. First function into derivative of second plus second function into derivative of first. Fine. So
Yes, sir.
let us discuss. So can you just tell me? You have got two functions in multiplied. Your first function is x and your second function is sine x. So you need to calculate dy by dx, right? So your f of x over here is x and your g of x is sine x. So dy by dx is f of x into d by dx of g of x into cos x. Great. Plus gx as it is.
1 into
Sin
Great.
into 1.
So it is x cos x plus sine x. Really simple, right?
Yes, sir.
Okay. Actually, we have done it so many times, it won't. So can you just do it, this one? Anyone?
Yes, sir.
So over here, your f of x is x square plus 2x, and your g of x
Cos
is
X.
cos x. So how do we do? We keep the first function intact. We keep the first function as it is. Fine. You keep the first function as it is. So you keep the first function as it is, and then you differentiate your second function.
Minus sin x.
After that, you keep your second
2x
function as it is.
Cos x
And
into
what about the derivative of this?
2.
2x plus 2.
Plus 1.
It is 2x plus 2, right?
Yes, sir.
Yes,
Yeah.
sir.
Great. Okay, so let us look at one more case, division case. Right? So how do we do when you have got two functions in division? So you take differentiation of top into bottom as it is minus, you do the other way around, whole divided by denominator square. Fine. ऊपर वाले का डेरिवेटिव इंटू नीचे वाला माइनस नीचे वाले का डेरिवेटिव इंटू ऊपर वाला होल डिवाइड बाय नीचे वाले का स्क्वायर. This is how I used to remember it. So let us do a few questions. So f of x is x square and g of x is
Sin
sin
X.
x.
Sin.
Have you done this in your college? Anyone?
No, sir.
No, sir.
No one?
Sir.
Okay, so this chapter you have not reached currently?
No, sir.
Okay, not an issue. So can you just tell me what is f dash x?
X square.
2x.
2x
Dash x.
2x.
It is 2x,
sir.
right? And what about
Yes.
g dash x?
cos
Cos
X. Cos X.
Okay, so your dy by dx. So first you take the derivative of the top, right? You take the derivative of the
2.
top. So 2x into. Now you keep
2x.
denominator as it is. Minus
Sin.
Cos X into
Cos x into
X square.
x.
whole divide by sine square x.
Sin square x.
Yes,
Right?
sir.
This is your derivative. Okay, great. Or okay, just a minute. Or let me invert it. Fine. So you have got f of x as cos x and g of x as x square plus 1. So can you just tell me what is f dash x?
Minus sin X.
Next.
And what about g dash x?
2x.
2x,
2x.
yes, sir.
2x.
2x? Right.
Yes, sir.
2x.
2x.
2x. So over here, you can just mention one small thing that I forgot. You can just mention that d by dx of constant. What is it?
0, sir.
0,
Zero,
sir.
sir.
Yeah. Why is it 0? Because the slope is 0, right?
Yes,
You
sir.
pull out a curve that's constant. Y is equal to some constant. So it's parallel to x-axis. So its slope is 0. So that is why dy dx of constant is 0. Okay. So let us see if we can do this. So you take the derivative of the top
Minus sin x.
into
X
x
square.
into
plus
X
1
square plus 1.
plus
minus.
x into
It is minus. Minus differentiation of denominator
2x
into
cos x.
whole divide by.
X square plus 1
Plus
whole
one whole square.
Great. Okay, great. So now I want that all of us will derive, okay, the derivative of sec x. Okay. I want all of us to do that. So we take function y is equal to sec x. So it can be written as 1 by cos x,
cos x.
right? It can be written as 1 by cos x. So you can
Yes.
write your f of x as 1 and g of x as cos x and try this. So what is your f dash x?
0,
Zero,
sir.
sir.
What about g dash?
Minus sin x, sir.
Minus sin x.
Great. Let us give it a try. So first you do the derivative of the top. So it is 0 into 0 into cos x minus. Then you keep the top as it is and you differentiate this thing. Whole
Yes.
divide by cos square x. So it is basically sin x divided by cos square x. So it can be written as sec x into tan x. Right?
Yes, sir.
Right? You can just split out one cos and one cos. So sin x by cos x becomes tan x and one cos x that you remains will becomes sec x. Fine?
Yes,
Yes.
sir.
Okay. Let us do one more case. Okay. So let us do tan x. Let us do tan x. Okay. Let us see how we can do tan x. So tan x can be written as sin x divided
Sin by
by,
cos x.
Cos x.
right? So dy by dx directly I will do. So I will tell you, first take the derivative of the top. What is the derivative of the top?
Cos x.
Cos
Cos
x,
x,
sir.
sir.
Cos x, sir.
Okay. And keep your bottom as it is.
Cos x.
Then after that, you differentiate the bottom
Minus sin
Minus sin square
and keep
x.
your top as it is, and then you just take square of denominator. So in the numerator, you will get cos square x plus sin square x. What is cos square x plus sin square x?
1, sir.
1,
Great.
sir.
1 divided by cos square x can be written as secant
sec.
square x.
Secant square.
Yeah,
X.
sec
X.
square x. Fine. Correct, everyone?
Yes, sir.
Yes, sir.
Okay. So tan x we have derived. Okay. Great work. Okay, let us try this case also. You have got y is equal to 1 divided by any function f of x. F of x is any function given to you. Can you try this? How do we do this? You f of x is any random function given to you. It is not told to you what that function is. So first you take derivative of the top. Can you tell me what is the derivative of the top?
0,
0.
sir.
Into, you keep your denominator as it is, minus. Now you differentiate your denominator. So it
F
can be
dash
written as f dash x.
Dash
And
x.
you keep your top as it is.
into
1.
1.
Whole divide by
F
f square x,
x.
right? So it becomes minus f dash x divided by,
F square
X
x.
square x.
great. Fine. So using this thing, I want you to tell me what is the value of dy by dx. 1 by f of x. It can be written as minus f dash x divided by f square x. So can you just tell me your f of x over here is x square plus 2x plus 3x plus 2. So what is f dash x?
So is
2
it
plus 3,
How much?
X
plus 3.
So what will be your dy by dx? Minus f dash x divided by f square x. So minus f dash x. F dash x.
Minus 2x minus 3.
Okay. Whole divided by f square. Fine.
Yes,
Yes.
sir.
Okay.
Yes.
So over here we have derived the formula for tan x, right? We have derived what is the derivative of tan x. And from this thing, I want to do a cot x. Using this thing, I want to do what is the derivative of cot x. So cot x can be written as 1 by tan x,
Yes, sir.
right?
Yes,
1
sir.
by tan x. So let us try. It is 1 by f of x, and f of x is tan x. So what is f dash x?
Secant square
Can
x.
Great, great. So dy
Minus
by
cos
dx is
is
minus f dash x. So minus f dash x divided by f square x, right?
Tan square x.
Minus f dash x by f
correct,
square
sir?
x, tan square x.
tan square x.
So you can just see it can be written as minus 1 by cos square x whole divided by sine square x by cos square x. So it becomes minus
Cosecant
cos x
square.
square
Minus
x.
cosecant square.
Right? Everyone.
Yes,
Yes,
sir.
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 So we have just one thing left, just one more function left.
Cosecant x.
Yeah. So it can be written as 1 by sine x. So using the direct method, minus f dash x by f square x. So minus, can you tell me what is f dash x?
Cos x, sir.
Cos.
By sine square x, right?
Yes,
Yes,
sir.
sir.
So like you can just split it out and you can check it is minus
Minus
cosec x
Minus
into cot
cos
x.
x.
into cosecant x.
Great. Everyone.
Yes,
Yes.
sir.
Okay. Today's class must be really easy. Like if you have attended the common syllabus to both JEE and NEET students, the syllabus that was common to both JEE and NEET students. So we have discussed this earlier also. Okay. Let us give it a try now. So now, okay. So let us see if we can do this case also. So you have got y is equal to x into sin x into let us take some other function sin x into e raised to x. Okay, fine, e raised to x. So you have got three functions and multiplied. So what can we do over here? You have got three functions that are multiplied to each other. So what can you do? So what we can do is I can assume this function as one function and the product of this thing as a function y2, right? So it is basically y is equal to y1 multiplied by y2. So dy by dx can be written as dy1 by dx into y2 plus dy2 by d1 by dx into y1, right? Just keeping one at a time. So I'll just write it as, can you just tell me what is the value of dy1 by dx? What
1,
is
sir.
y1? Ah, great. Y1 is only x.
X.
Y1 is only x. Okay,
One.
it is only x. So it is 1. 1 into y2. Your y2 is
Sin
Sin
x
x.
in
sin x into e raised to x. Okay, plus y1 x into derivative of
sin x into e raised to x.
can we now compute this thing?
Yes, sir.
Yes, sir.
How can we do it?
X
How
is
can we
equals to
Sir,
Derivative of sin x into e raised to x plus derivative of e raised to x into sin x, sir.
great. So you can just treat this as a derivative and find it, right? So you can treat these two functions as product and treat both of them differently. So you can see you can do it as cos x into e
Cos
raised
x
to
e
x
raised to
plus
x plus e
sin
raised to
x
x sin
into
x.
yeah, great.
e raised to x.
So just substitute this value over here. Let us see what we get. So you will get it as sin x into e raised to x plus x into this whole thing,
cos x.
right?
Yes, sir.
So
Sir,
now we can just open up the brackets. See, anyone who has done this, who has covered this syllabus in their college? Anyone?
No, sir.
Okay,
No, sir.
okay, not an issue. So we have got this dy by dx as this term of three things. So I just want you to have a small look into this, into the original function that was given to you. The original function given to you was x into sin x into e raised to x. And then you can just look at the final answer that we get. It is this long thing over here. It has three terms in total, right? Sin x into e raised to x plus x into e raised to x cos x plus x into e raised to x sin x. This is what we have. This is what we have. So just take one small minute and think about it. You have got three functions over here in multiplication. First function is x, second is sin x, third is e raised to x. Now I want you to think for a while what will happen if you just take the differentiation of one function at a time. Okay, differentiate one function at a time and keep the other two as it is. Fine. So in the first case, let me just tell you how, what is the trick for this. So what you can do is differentiate only one function at a time. And keep all others as it is. Okay. So your first function you have is x. Can anyone tell me what is the derivative of x?
1, sir.
One, sir.
One, sir.
So you write it as 1 and keep the other two
One,
as it is.
X into e raised to x.
Okay. Now your second function, what is your second function?
Sin x.
What is the
Sin.
derivative of sin x?
Cos
Cos
x.
x.
So now
Cos x.
you keep the other two as it is and differentiate their second function.
X into e raised to x.
Raised
Cos.
to x cos
What is your
x
third
plus
function?
X
What is your
into
third,
e raised to s sin x.
what is
E
your
raised
third function?
e raised to x.
Sin x.
Okay, so its derivative is also e raised to x. So it will,
to
so you
x
keep
in.
the first, right?
Yes, sir.
Now you can just compare it with your final result. It is the same thing.
Equals.
Yes,
Yeah.
sir.
Yes, sir.
So this is what you can do whenever you have a product. Whenever you have a product, what you do, you can just differentiate only one function at a time. Okay. Let us see. So you have got y as x plus 1 multiplied x plus 2 multiplied x plus 3 multiplied x plus 4. So can you just tell me dy by dx directly? So you have got four functions in multiplication, but instead of going into the long calculations, what we can do, we just need to differentiate one function at a time.
Yes,
So over
sir.
here, you have got this first function, this second function, this third function,
Fourth
and this
function.
fourth function. Yeah.
Function.
Sir,
So
is it 4?
is the derivative of the first function?
So answer is 4.
Sir.
How much?
1.
4 answer.
4. No. No, answer is not 4.
1,
Okay.
sir.
1.
Can you just tell me what is the derivative of the first thing?
1, sir.
1,
sir.
sir.
1.
Yeah. So you just differentiate your first function and keep the others as
Yes.
it is.
Yes,
X
sir.
into x plus 3 into x plus 4.
Right. After that, what will you do?
Second
1.
function.
Derivative of second function.
Yeah. Right.
Yes.
Yes, sir.
Now you differentiate your third function.
X plus 1 into x plus 2 into
X plus 4
Great. And after that,
plus
you differentiate your fourth function.
Fourth function.
X
X plus 1,
X
x
plus
2, x plus
plus
3,
3.
X
x
plus
plus 3.
Right.
Yes, sir.
You have got this really long thing. So this really long thing can actually be written cleverly in a much smaller method. I'll show you how it can be written. You can just see that in every term, one of the terms is disappearing,
Yes, sir.
right? One of the
Yes,
terms
sir.
is disappearing, so it can be written cleverly like this also. Right? See, because you can just take this thing inside and check. One of the terms will get cancelled in each of this addition.
Yes,
Right?
sir.
In your first term, x plus 1 will get cancelled. In your second, x plus 2 will get cancelled. In your 3, x plus 3. And in your fourth term, x plus 4 will get cancelled. So overall, you will get this whole sum again. Right?
Yes, sir.
Yeah. So this is the differentiation of this whole thing. And it can be written in a very small method like this also. Actually, I just, since we have done integration, so I just wanted you to, I just wanted you to tell you that there has been a question like this also. So like if you don't know integration, don't worry. But if you know, like there was just a very small question in JEE Main 4 or 5 years back that they gave you the integral of this thing. They asked you what is the integration of this thing. So anyone who knows what is integration?
Summation.
Integration is, what is it? Gayatri?
summation.
So summation, sir.
Summation is the physical interpretation, but like in functional sense, what does it mean in functions? Okay, so like for if you don't know, differentiation, like integration is the reverse process of differentiation,
Reverse forward.
right?
Sir.
So for example, you are differentiating a function y, so you get dy by dx. So if you integrate it, you'll get to y again. So
Yes,
basically,
sir.
you are trying to find such a function. You are trying to find such a function which, when differentiated, will give you this function. So basically, I am asking you to you give me such a function that I differentiate this function and I get this. Fine.
That
This is
is
what I'm asking. Can you tell
X
me?
plus 1 into x plus 2 into x plus 3 plus into plus.
x plus 4, sir.
Yeah.
The question that had given to.
Yes, yes. This is it. Fine.
Yes, sir.
Actually,
Yes, sir.
if you have not studied integration till now, so this question will, you will find it really simple. But if someone has done integration, like it is really complex question. So that is why I was just sharing it before. So once you study integral, just look into this question back. This was just for reference. Okay. Okay, great. So anyways, time is over. So I would just want all of you to like solve your NCRT questions. We have done product and division rule. Tomorrow we will be revising with chain rule, even though we have done it quite many times. Okay, so that is quite important. So before that, I would just want all of you to do that. And yeah, before coming to tomorrow's class, I would want all of you to be able to derive all trigonometric formula that have not been derived today. Okay. So for example, we have done cosec x today, cot x we have done. So all those trigonometric formula that were not derived today, I want you to derive. Fine. So that's it for today. Ma'am, please
Sir?
end the class. Yes.
Sir?
Yes.
You mean you want to be derived, we want to be derived the functions or the formulas
I mean, I want you to uh, like derive the derivative, like differentiation
of what, sir?
of all the trigonometric formula or trigonometric functions,
Okay, sir.
of all trigonometric functions. Okay. Ma'am, please end the class.
All right. Thank you, sir.
Okay, thank you. Thank you.